a brief introduction. Some of the labs, not all, for example, TCP use MININET. perfSONAR labs do not use MININET. They use real virtual networks connecting virtual machines. But lab number 1 of TCP is about MININET. For those who are not that familiar, what is MININET? It is a testbed. It is inexpensive. It runs real protocol stack. If the operating system of the machine is a Linux machine, then all the nodes in MININET will be running Linux. Each node in MININET is a separate network namespace. That means that each node has a virtual interface or interfaces, more than one in the case of switches and routers. Each device has its routing table. Where are these tools, or MININET, where is this tool used? There are plenty of examples. We listed some of those here. There are people reproducing network research, talking about buffer size, congestion control, the behavior of protocols in long-fat networks, in data centers. There are other people doing SDN with MININET. Programmable switches, for those who are familiar with p4.org, MININET is a key tool for developing new ideas. And teaching and research at undergrad and grad levels. A very simple example. What if I want to test the performance of Cubic, BBR version 1, BBR version 2, as the packet loss rate increase? This is fairly simple to do with the tools that we will be covering today. Now, all the labs related to TCP, again, will be using MININET. A topology, for example, we have here two end devices, H1 and H2, connected by a switch. Behind the scenes, what is happening is that in MININET, we will have H1, H2, and the switch, and we will have a Intel Xeon processor running on those devices. That is an introduction to MININET. Lab number 2 is an introduction to IPERF. This is one of the tools that we use in many labs. So what is IPERF? Is a real-time network throughput measurement tool. We have two types of users: the client, which is the sender, and the server, which is the receiver. In this case, we have an example of a client sending data to a server. Roughly the capacity of the pods, you will see that is almost about 50 gigabits per second. So you can test protocols performance up to those rates. Other tools, lab 5 talks about other tools, and I'm jumping again because of the time constraint. We cannot cover all the labs, but we're mentioning this lab 1, 2, and 5 just because there are some very interesting tools. For example, in lab number 5, we have the token bucket filter, which is the way that we limit the rate in the virtual environment. Let me explain. The token bucket filter, I will talk more about that in a few minutes, but it will set the rate of a network. If I want to test my protocols with links of 1 gigabit per second, then I will use the token bucket filter and put a limit. Another tool is the network emulator, or NetEm. And NetEm is a network emulator that reproduces long distance wide area networks in the lab environment. For example, on the left-hand side, we have a long distance 100 milliseconds round trip time between H1 and H2. So what we will have if we have a simple ping is 100 millisecond round trip time. We can emulate losses, and we will see just a lot of retransmissions. Where are these tools used? There are many examples. There are some listed at the bottom here. Here at the University of South Carolina, we use much for undergrad and graduate research. There are some examples. I borrowed this from ESNet. This is a talk of 2015, a very interesting one. And Doug was mentioning faster data. Actually, I think this is also in faster data. And this is a comparison. The reference is at the bottom. This is a comparison between two types of tests. One over the real network, ESNet, a second one, an emulated network where the round trip time is emulated using NetTem. Independently of what are we measuring, what we want to show here is just that is fairly similar. The algorithm that we will use to set the rate, as I mentioned before, is the token bucket algorithm. And this algorithm allows us to limit the rate. I want a network of 2 gigabits per second, or a link of 2 gigabits per second, or 5, etc. That is the link rate. The maximum burst size, and also the buffer size. The buffer size is if I am using a node as a router or as a switch, well, then I can allocate X amount of megabytes for a specific interface. So, and you can test many of the ideas that we talked this morning. In the snapshot, on the right-hand side, we have a network at 10 gigs. So the way to emulate this would be setting the rate with the token bucket algorithm, and we should get something like this, a little bit less than 10 gigabits per second with the overhead. So the lab file, and I will switch to Elie in shortly. But this lab, the one that we will be discussing, Elie will showing us the environment is consists of 2 switches, S1, S2, 2 end devices, H1 and H2. And we will use NetTem to establish a latency of 10 milliseconds between the switches. And we will set the limit, the rate to 2 gigabits per second. And then we will test performance, and this should be reflected in the performance. Before we switch to the virtual platform, a few words about the availability of the virtual platform. Many of you received the emails on how to access the platform. So please check your email. And if you have any questions, I refer to the assistant 1 to 4, and they will help you how to access. But you have these instructions in your email. Those are for the first 110 attendees, those that were registered first. Now, for those who don't have access yet at the platform, you will have access after May 6th. And that will be from May 6th, this is, I should correct this, from May 6th to August 6th, availability after. And credentials will be sent to you, but it's gonna be this URL, username, and password. So I will switch to the the virtual platform right now. And again, to log in, you have the credentials in your email, and if you have questions, please feel free to message the assistants 1 to 4. So the first time that you log in, we have to set a new password. Email is optional. Some settings. And then schedule a lab for myself. If I want to schedule a lab that will talk about network tools and protocols, which is this first session that we're discussing here. Also, if we want to do a lab related to perfSONAR, let me pick up for a second perfSONAR. We have the different labs. Diagnosis code, we're talking about MAT-dash, monitoring and debugging dashboard. So we can make a reservation for today from 2, or we can go even earlier to the specified time. And I think the limit is about 3 hours. I will cancel this. But again, you have the description of how to log into this also in a user manual that was emailed to you. A link to the user manual was emailed to you. So what I will do right now is I will switch to Elie, and Elie will walk through lab number 5, the one that we discussed before. Elie, are you there?
Yes, thank you, Doctor.
You want to share your screen?
Sure. Can you see my screen?
Yes.
Okay. So we will go over lab 5 in this demo. First, we have to launch MININET, and MININET is a graphical user interface editor for MININET topologies. So here we have the password. All of this is documented in the lab manual. The default password in all these is just password for simplicity. And we have to go to File, Open, and you can see here all the different labs that we have. And each one of these has a different topology, so we have to make sure that we select the right lab. For now, we will do lab 5, so I'm just gonna double-click on lab 5. And this is the topology that we have. We have 2 end hosts, H1 and H2, and we have 2 switches, S1 and S2. So usually, if you want to create your own topology, you can click here, let's say, on a host and drag it. You can also add the switch, and you can do further things such as SDN-related stuff. But for now, we will only be dealing with switches and end hosts. So once we deploy our topology, we select what are the nodes. We have to start the emulation. So we hit
Elie, can I interrupt just for
Sure.
a second? Could you show us where to find the lab manual if you minimize this and
Yes.
show the entire environment?
Sure. So once we do the reservation and we open the machine, so we can see here we have topology. Since we are using MININET, so everything is emulated into one host. This is why we have only client 1. There's also here content. So if we click on content, we can see the actual text for that lab. So for example, this is lab 5. We can see here what are the objectives, the roadmap. As Dr. Jorge said, at the beginning of each lab, we have an introduction to cover some basics about the theory of that lab. And after that, we have a lab topology. In the lab topology here, we can see the deployed topology that we show in MININET. And from there, we have all the steps. So everything that I did so far is opening the MININET and running the emulation. All of this is documented here. You can switch back to the client by clicking here on client, or in case you're using a more complex pod where you have several machines, such as in perfSONAR, you will be able to click immediately on the host that you want to launch. So if I click now on client 1, I will go back to the machine itself here. All right, so we loaded the topology, and then we are ready to start the emulation. So we click on run. And as you can see now, the buttons here are disabled, which means that the emulation started. Now, if I want to issue a command on H1 or H2, I have to open their terminal. And as was explained previously, these are represented as network namespaces. So each one of these end hosts will have a separate network stack. Let's say I want to start H2's terminal. So right click on H2 and I select terminal. Now we are into host H2. So if I use, for example, ifconfig, we will see that we have the interface H2 with H0 with the IP address 10.0.0.2. We configured by default in all the lab series here, the IP address is to start from 10.0.0. Followed by the actual number of the hosts. So here H2, we have .2, H1 will have, of course, .1. So let's say I want to open H1 as well. So now I have both of them. Let us test connectivity first. So you can issue a ping command 10.0.0.2. And you can see that we have here connectivity between the two end hosts. I will just cancel this by hitting Control-C. And the next thing we have to do is we have to use NetM to emulate round trip time, to emulate a delay in this network. So basically, we will be injecting the delay at the interface of S1 facing switch S2. So we will use NetM to apply a rule here that will inject 10 millisecond delay. Now, to do so, we have to go to the terminal of the client. And this is the terminal of the host itself, the whole machine, not for host 1 or host 2. And from here, we can issue the command such as, NetM related command or a token bucket filter or whatever, and apply the rule to the switch's interface. So I'm going to write here sudo tc qdisk. So TC is a tool in Linux that would allow us to configure what we call queuing discipline. And all of, NetM, TBF, all these in Linux are expressed as queuing disciplines. So what we will do here actually is try to combine several queuing disciplines and apply them to one interface on that switch. So first we will start by adding NetM. So I will write sudo tc qdisk add dev. So add device, and here I specify the interface of the switch. So we have S1 ETH2, and this is the interface that connects switch S1 to S2. I will apply it on the root because that's the first queuing discipline that we have. So I will attach it to the root. I will create a handle for it. I will call it 1. So the handle here will be used later, as we will see next, to try to combine several queuing disciplines. So if we want to say, I need to limit the rate with emulating some delay, we will use that number to combine them both. And after we write the handle and its number, we will write netm. And by the way, you can always use the tab command to see some suggestions. For now, we will just be using delay. So I will use delay, and I will write 10 ms to emulate a 10 millisecond delay. So after doing that, let us go back to the H1 terminal and test the ping. And as you can see now, we have 10 milliseconds because we emulated the 10 millisecond delay on the switch. And the packet going from H1 to H2 is passing through that interface where we emulated the delay. So as Dr. Jorge said, with NetM, we can do much more than emulating delay. You can have different loss rates. You can have reordering, jitter, corruption, and other kind of metrics that you can assign. Now, next we will try to limit the rate between S1 and S2, and we will set the link rate to be 2 gigabit. So
Elie,
again,
just one, there's an observation in the chat window. This is too fast, I'm not able to follow, but could you show what you are doing that is a step-by-step describing the content? So maybe you wanna just show again the document if somebody for some reason is not able to follow where to refer.
Okay, so again, we have to go to content here so that we will see the so that we will see the lab manual itself. And basically what I did here is, after I started MININET and I launched the emulation, I did a ping test between H1 and H2 to show that there's connectivity first and the round trip time is very low. And after that, we have to apply some rules on the switch to emulate delay or emulate packet loss or any kind of metrics that we want to emulate. So we will do that by assigning rules to the switch, and all these are described in the lab manual here. So it's step by step. We show, for example, here, let's say we want to identify the interface on the end host. So on H2, if we issue ifconfig, we can see that the interface name is H2 to H0. And we can see the IP address assigned to that interface. So next, let's say we want to emulate a high latency WAN. So we need to limit the rate, for example, to 1 gigabit, to 10 gigabit, to 2 gigabit, whatever value that we want. We have to issue a TC command on the client so that we assign the corresponding queuing discipline. So either TBF or NetM or even AQMs later. So some details regarding the calculation are all listed here. So for example, how can we derive the burst depending on the limit, depending on the rate that we're gonna configure, how to specify the buffer size. All these are explained in the lab, but essentially, if we wanna follow the rule of thumb, we have to specify one bandwidth delay product, one BDP for the buffers. So we do the calculation and accordingly we will set them as I will show next. And after that, we can start a throughput test by using IPERF. So we will have to start an IPERF server on one host and start an IPERF client on the other host and do the measurement. And then we will be able to see what is the achieved throughput. So this is related to rate limiting, as we saw. But next, we will show also how we can combine several queuing disciplines so that we can limit the rate at the same time, assign or inject some emulated losses or inject some emulated round trip times. So if I want 20 milliseconds with 10 gigabit, you have to combine these two queuing disciplines to do that. And of course, we show if we want to delete some queuing discipline, this is also listed in the lab. I hope that I covered at least the basics before I move over to the demo. I cannot see the questions. Okay.
Thank you, Elie. Yeah, that's good.
Okay, so I will switch back to the client. So as we saw, we assigned the 10 millisecond round trip time, and we verified that this emulated round trip time was shown when we issued a ping command from H1 to H2. Now, the next step is to limit the rate between switch 1 and switch 2. And again, this is our topology. So we are assigning the rules here on this interface. We did 10 milliseconds. Now we have to assign the rate to be 2 gigabits. So I go again to the terminal in the client, and I write sudo tc qdisk, and then add dev s1 eth2, because we are adding now another queuing discipline, which is the token bucket filter, TBF, for that same interface. Now, in order to do the combining of NetM and TBF, we have to specify here that we we need the parent of this current QDisk to be 1, which is the number that we assigned for the netm handle. So I'm saying now that this current queuing discipline that I'm adding is in fact a child for a previous one that has a handle number 1. And we can also keep doing that. So I will assign, let's say, handle 2 for this one. And I can keep on going in the tree and add several queuing disciplines by using these handle numbers. So after that, we have to specify what is the queuing discipline that we want. So I'll be using TBF, token bucket filter, as we said, to assign the rate. So TBF, and then I can use rate. As you can see, I'm pressing RA and tab, and I have auto completion so that it will be easier for you to navigate into the available options. And here, I'm going to write 2 gigabit because I need to limit the rate to 2 gigabit. I will specify the burst to be 1 million. This is expressed in bytes. And basically, the burst is the number of bytes that can fit into the bucket. It's explained in Lab 5 how the algorithm works. And basically, you have buckets, you have tokens inside that bucket, and you will consume tokens in order to limit the rate. So the burst is just to define what is the number of bytes that can fit into that bucket. How do we derive this value? It's also explained. So it's basically specific to the configured rate. So for 2 gigabit, you have to use this value. For 10 gigabit, you have to use another value. But essentially, it's just you have to make sure that you specify a high value to be able to get the throughput that you want. And it should be at least the specified rate, so 2 gigabit, divided by the clock rate of the system. But again, this is all explained in detail in the lab manual. And after that, we have to specify limit. And here, the limit parameter will allow us to specify the size of the buffer. So we're going to use here 2,500,000. And that value here represents 1 bandwidth delay product. So if you want to calculate 2 gigabit and 10 milliseconds, you will have this value in bytes. So now we added another queuing discipline. And let us go back to the end host. So to test this throughput, I will use H2, host H2 as an IPERF server. So IPERF 3-S for server. And in host 1, I will use it as a client. So IPERF 3-C. And I have to specify the IP of the server. So 10.0.0.2. And as you can see, now the achieved throughput here is limited. We cannot go above 2 gigabit because that's what we configured for that specific interface. At the same time, when we launch a ping command, we can see that the emulated round trip time is 10 milliseconds. So the interesting thing about MININET and all these tools is that you can actually emulate any type of network. But you have to make sure that you have enough resources because sometimes you don't have enough CPU and you will start seeing random losses. So as long as you have enough processing in your machine, you will be able to even configure rates up to 10, 20, even 40 gigabits per second. I'm going to conclude here. So we showed in this demo netm, which is a tool to emulate packet loss, delay, jitter, and other metrics. We showed how to use netm in conjunction with TBF to limit the rate and specify the buffer size. And finally, we did a throughput test to verify that we limited the rate correctly.
Thank you, Elie. Now we have few minutes. Probably is a good idea if we switch to the perfSONAR, so those who are interested in perfSONAR can also experience
Sure.
the pod. So let me switch the presentation. We have perfSONAR, and well, Jose will be leading this demo. So what Elie was showing is we have a whole set of 20 labs. Again, because of the time constraint, we cannot go through all of them. But if you are curious about many of the topics that we talked today, buffer size, buffer bloat, performance of cubic, performance of BBR under different scenarios, those are discussed in many of those labs. perfSONAR, we have also a lab series that we developed, and it shows from the very basic of perfSONAR, the initial configuration using the graphical user interface, all the way to a little bit more advanced topics, for example, configuring the limits file or running a mat dash. The organization of the lab manuals are similar to network tools and protocol labs. There is a first section, an overview, then the background information, section 1, and then the next sections, step-by-step instructions. So the pod for perfSONAR is a little bit different. Rather than using just one device with MININET, we have multiple networks, because if we want to run a mat dash, for example, we want to collect information, perfSONAR information from several domains, and that's what is described here in this slide. We have perfSONAR 1 in one network, perfSONAR 2 in a different one, and perfSONAR 3. So it's a multi-domain. There is live connectivity to the internet. If you want to try a test perfSONAR measurement to perfSONAR node in the internet, that's doable. There is a central management node where all the perfSONAR information is collected for the mat dash. And there is a client that is used for accessing these devices using the graphical user interface. I will switch to Jose. Jose will show a demo. Jose, I don't know if you want to show one in particular, 4 or 5, or you want to show the mat dash.
I can show how to run some PSCHEDULER commands, and
Okay.
also we can jump to the dashboard.
Yeah.
So basically, we can create a reservation for perfSONAR as you did for NTP. So for example, we enter to the lab, and we will see the topology, which consists in this case 7 virtual machines. These are composed by 3 perfSONAR nodes, a client host, and 3 routers. And in this case, I will run a PSCHEDULER command using the perfSONAR 1 node just inside the network. I will run a throughput test where the destination node is perfSONAR 2, which is this node. And we can see that we can submit this task. We'll see that the tool that is used to measure the throughput is IPERF3. And we can see that the task is scheduled right away, and we are just waiting for the results. You have access to more details of this command, of course, here in the contents, where you can see an overview, objectives, and a brief introduction about PSCHEDULER commands. And we talk more in depth about the commands. So let's jump back to perfSONAR 1 to see the results. So we can see the results here. So in addition to that, we can run also a PSCHEDULER task testing a node that is outside the network. So outside the local network. So in this case, I will test to this destination, nettest.lbl.gov. I will run as well an IPERF test, and we can see the results. So if somebody has more interest, you can search on the global directory for additional perfSONAR nodes and run tasks such as latency and also traceroute. So we can see the results here. It displays the throughput and the time interval is just 10 seconds. So all these labs, lab 4 and lab 5, are based on PSCHEDULER commands. So let's jump to the next activity, which is MAT-. In this case, we run the same topology here. However, in this for this lab, we have perfSONAR2, which is running the central management and is collecting the data from perfSONAR1 and perfSONAR3. So we will use a client host to display these results in a dashboard. So I will just click on this client host. I apologize. Just a minute here. Oh, here we go. Okay, let's resume here. I will jump to this client host where I already configured to run the dashboard. You can see that it's just a Linux machine that is collecting the data. It's showing the data, in this case, that is provided in perfSONAR2. So we can see the dashboard here. We can see the test among all the nodes. And also, if we click on one of these graphs, on these squares, we can see the timing diagram. In this case, is from perfSONAR2 to perfSONAR3, which correspond to these IP addresses. And we can see here the throughput, packet loss, and latency. And we can see the details, we can see the point of failures, and we can filter out these graphs. So we can really know if there's a failure, and we can see what time that happens, and it displays all the timing information about this. So that's all that we have for MAT-, and let me know if you have any question.
Thank you, Jose. Jose, what you were discussing is, could you go back to the list of labs of perfSONAR?
Sure.
You discussed, I think, just to clarify,
Yeah.
you went through different labs here.
Yeah. First, I show lab 4 and lab 5, which englobes PSCHEDULER commands. And the last one was MAT-. So we have a lab on MAT-. It shows how to run the PSCHEDULER task, psconfig archive, in order to collect them into a central management node, and also how to display them in a dashboard.
Thank you, Jose. Let me get back to the control. So I think probably was pretty fast, but for the time constraint that we have, but what Elie and Jose were discussing are subset of the labs that you have available. Elie was discussing the number 5, which is one bandwidth with token bucket filter, but all these first labs really are more tools on how to deploy emulated networks. And then I would say the second half is more routers issues and fairness and active queue management labs. For example, TCP fairness is lab number 10. Router buffer size is lab number 11, and there is where you can see, for example, the performance difference between traditional congestion control and BBR, buffer bloat problems in traditional congestion control, how BBR improved the performance in that regard. And the last few labs are more active queue management. Random early detection, stochastic fair queuing, and a few others. For perfSONAR, Jose went through 2 labs, but there are several others. What we plan for tomorrow is to spend much more time on the hands-on, and we will cover the border gateway BGP border gateway protocol, and we will try to do at least 3-4 labs here during the workshop. Those who have access to the platform, you can log in at any time and do these labs. For all the people that registered, you will have access from May 6th to August 6th to these labs. The third day is going to be the security day, and we will be discussing the BRO and SIG labs. So I will stop for a moment. I don't know if there's any question. We're reaching the end of the first day. Okay, Jason, I don't know if you have anything to share. So I think this is the last activity for today. We're back tomorrow at 1 p.m. Eastern time, and tomorrow will be BGP.